guys, this is Cam from ECA. This video is going to be on trigonometry, so let's get started.
So we know that the longest side of a right angled triangle is called the hypotenuse. We can then label the opposite and adjacent sides, which are opposite and next to the angle in question. Now we can write down the sine, the cosine and the tangent, which are all ratios of the side lengths. These are known as the trigonometric functions and are extremely useful. We can remember them using the acronym SOHCAHTOA. Let's say we have a right angled triangle and we know one of the side lengths and an angle and we want to find the other side here. The two sides in question are the adjacent and opposite side, so we can use tangent in order to find the opposite side. First, write down the equation for tan and then substitute in values and rearrange to find the answer. You'll need to use your calculator. We can also use trig to find a missing angle. Here we know the value of the hypotenuse and the opposite side, so we need to use sine. So we know what sine x is, but how do we use this to find x? Well, we need to use the inverse trig functions. These do the opposite of the trig functions and are written with a -1 here, although this is not the same as to the power of -1. Once we've done this, we can use inverse sine on the other side of the equation in order to find what x is. There should be a button for inverse trig somewhere on your calculator. In the non-calculator paper, there are some common angles that you'll need to know sine, cos and tan for. First, let's work these out for 30 degrees and 60 degrees. We need to draw an equilateral triangle with side length 2. Then, let's split it down the middle and draw out the left-right angled triangle. Then, we need to use Pythagoras' theorem in order to find the height of this triangle. Substituting in shows that the answer is the square root of 3. Now, because we know all of the side lengths and all of the angles in the triangle, we can read off sine, cos and tan for both 30 degrees and 60 degrees. Working them out like this can save you having to remember them in an exam. Now, let's look at 45 degrees. First, draw out a square with side length 1 and then let's isolate this right angled triangle. Again, we need to use Pythagoras' theorem to find the hypotenuse, which turns out to be root 2. As we did before, we can then work out sine, cos and tan for 45 degrees. You'll have to remember the values for 0 and 90 degrees, and notice that there is no value for tan 90 degrees. At higher level, you might have to use trig in 3D diagrams. Here we have a square base pyramid and we want to find the angle x. First, we have to draw out triangle A and B. We need to find the length AM in order to find x. So let's do this using Pythagoras' theorem. Let's first split the triangle A and B in half. Then we can use Pythagoras' theorem to show that AM is equal to root 2. Now, let's draw out triangle AME. This has the angle x in that we want to find, and now we know the value for the opposite and adjacent side lengths. So we can use inverse tan in order to find x. Again, you'll need to use your calculator to do this, as it's not a nice value.
Thank you for watching this ECA Maths recap video. Check out our YouTube channel for more maths recaps, or get the ECA app on the Apple and Android app stores to get unlimited on-demand maths tutoring right from your smartphone.